Hey everybody, welcome to the channel. My name is Andrew and I'm going to build a pedal steel guitar. So a couple months ago I visited Nashville, Tennessee, the country music capital of the world, and it was a pretty cool trip. We heard a lot of good country music, bluegrass music, and we had the opportunity to hear some live pedal steel guitar, which I've never heard before. And although I've heard pedal steel being played before, I've never heard it live, so that was pretty cool. And I decided, hey, maybe I'll buy one of these and learn how to play it. The problem is they're really expensive. So I looked on eBay for some used pedal steels, and I found that the cheapest thing I could find was anywhere from $800 up for a used one. And then for a new one, they're even more, up to $2,000, $3,000, $4,000, $5,000, $6,000 depending on the quality. So I decided to build my own. For those of you who don't know, a pedal steel guitar is a guitar that's played flat with a slide. It's typically 10 strings. It's tuned to a sequence called E ninth. Here are some examples of some pedal steels. So it's typically either one or two necks. And you can see that usually you play the left hand has the slide, and then the right hand you got finger picks. You got your tuners up on the left side of the player here. And then on the right side you got your pickup, and then you have these roller changers here. So on both the nut side and the bridge side, the strings go over rollers so that the strings can be stretched and relaxed by the pedals and the knee levers without causing damage. And so the way that this instrument works is that you have pedals on the bottom here, foot pedals. You have a volume pedal with the right foot, and then underneath, which you can't see, is there are a bunch of knee levers, and so each pedal will increase the pitch of a specific string, and each knee lever will decrease the pitch of a specific string. A similar instrument is a lap steel. Lap steel is typically 6 strings tuned to C6 tuning, and this preceded the pedal steel. The key difference between the lap steel and the pedal steel is that the lap steel has the strings fixed, so there's no bending typically of a standard lap steel guitar. So you can see the strings on the bridge side are mounted fixed to the body, and then on the nut side they go over the nut and they attach to the tuning pegs. This is also played with a slide, but you don't get the same bending action that you do with a pedal steel. Now I say typically the lap steel you can't bend the strings, but I have seen some products like this one, which is a palm bender. So this is a set of benders that's aftermarket, and you can install on your guitar afterward, and this will bend 2 of the strings up in pitch. And so that's pretty cool, except there's still a lot more possibilities with a pedal steel because you can have many more pedals and you can bend both up and down in pitch. Now the other cool thing about both lap steel and pedal steel is that there's no frets, there's no metal frets. So on a standard guitar, you push the string against the fret, and that's what shortens the length of the string to give you the change in pitch. In the case of any slide guitar like this, like a lap steel or pedal steel, there's no frets, so the strings are suspended above the fingerboard, and the only thing changing the pitch is either the benders or the pedals that you're using, the knee levers, or primarily the slide that you're using to play it. The final instrument that's relevant here is a Dobro. So this is kind of like the acoustic equivalent of a lap steel. So this is a 6-string guitar, no frets. The strings are also suspended quite a bit above the fingerboard, and this instrument is also played with a slide. Very popular in country and bluegrass music, and pretty cool instrument, except not electric, and you don't have the pedals. You can't bend the strings in any way. So the Dobro is strictly played with the slide. So I was wondering, why are these things so expensive? I mean, a regular guitar, you could get a cheap regular guitar for a couple $100. You can get a cheap lap steel guitar for $100, $150. So why are these pedal steels so expensive? And so I did some research, and I found that there's a lot of intricate components in these. So if you look at the underside of one of these guitars, here are some pictures, you can see all the intricate mechanism that basically transfers the force from the pedals all the way up to the changer on the right side of the guitar at the bridge. that actually bends the strings. So my assumption is that all of these intricate machine components is what really drives up the cost of these guitars. So I decided the best way to eliminate all that cost would be to eliminate all those components. And so my plan is to build a servo motor controlled pedal steel guitar. So the idea would be to eliminate all these components. I'd have a pedal position sensor on the floor, step on the pedal, send a signal to an Arduino, which would then control a servo motor that would bend or loosen the string. Now if my design works, this actually opens up a lot of other cool possibilities as well. So a standard pedal steel guitar, an inexpensive one typically has 3 pedals. The nicer ones have, 2 necks and a bunch of pedals. This one, 1, 2, 3, 4, 5, 6, 7, 8 pedals. But if I design this with servo motors and it's all electronic, then it opens up the possibilities of auto tuning potentially. So I can write a software program that would tune the strings for me based on, I can use a microphone as a pitch sensor to determine whether each string is in tune. I could have custom pedal profiles to determine how sensitive the pedal is in terms of bending each string. And I could replicate the mechanism on every string. I could potentially have every string have the ability to either bend up or down without necessarily having to add a whole lot of additional components. So come watch me as I go through this process of building this guitar, and I hope you enjoy it. Thanks for watching. Say hi to the bunny. Hi, bunny. Bye, bunny.